Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistants, and today we are looking at ionization energy. Between fluorine and chlorine, which atom has the smaller first ionization energy? And they're asking also between sodium and magnesium, which atom has the higher second ionization energy? So let's take a look at them on the periodic table. Let's start with fluorine and chlorine. So fluorine and chlorine are right over here in the corner. And they're considered group 7A. And every element in group 7A is going to have the same valence electron structure. But as you move down the periodic table, as we discussed in the previous video, your atomic radius gets larger, which would imply that chlorine, in the case of chlorine, the electrons are further from the nucleus than in the case of fluorine, which is exactly what we find experimentally. So in that instance, knowing what ionization means and knowing that ionization energy is the energy needed to make that atom into an ion, what we're looking at here is taking this chlorine and turning it into a chloride, or this fluorine and turning it into a fluoride. And because the electrons are further out from chlorine, you can imagine that the nucleus of chlorine has a more tenuous hold on the electrons in the valence shell. So knowing that the valence electrons are not held in quite as well as in the case of fluorine, we can very readily say that in part A, that chlorine has the smaller first ionization energy. So, and bear in mind that this question is completely qualitative. It is not quantitative at all. It is simply knowing what the trends on the periodic table mean and understanding what the definition of ionization energy is. And if you can put those parts together, you can easily see that chlorine would have the smaller first ionization energy, simply because those electrons are further out. Nucleus has less of a hold on it. In the case of fluorine, all the electrons are pulled tight in, so it would be very difficult for fluorine to become ionic. Even though it readily does become ionic in many instances, the idea is with respect to one another, which one is going to be easier to make ionic than the other. Okay? So in part B, we're asked to, between sodium and magnesium, which atom has the higher second ionization energy? So let's take a look at sodium and magnesium. This one's a little more tricky. This one's designed to be a little more tricky. Sodium and magnesium are over here. They're on different groups, but they're in the same period. And generally speaking, until you get up to higher level chemistry, you're only going to ever be asked for things that are either in the same period or same group or close enough that you can make a rational decision based on that. So period 3, we're looking at, let's go back to our original slide. So in the case of period 3, let's take a look at what we're actually addressing here. So with period 3, we're looking for sodium as a +1 going to sodium 2 plus an electron. That's the same thing, right? That's what's happening is the release of an electron and sodium's going to its second ionization energy. Let's make that sodium, not nitrogen. And looking at the electron configuration, we're going from a 2s2 to a 2s1. Let's take a look at magnesium. Magnesium would be going from an Mg plus to an Mg2 plus an electron. And this is going from a 2s to 3s1, sort of a hybrid. That's why you generally don't see magnesium in this sense, versus a 2s2. So your 2s2 is going to shield your 3s more effectively and easier. So knowing those types of things, knowing the how this structure works, it's a little more complicated, but when you look at it, you can readily see that it is far more stable to be at this than to be at that. This is where magnesium wants to be. Okay? So, knowing that the 2s shields the 3s more effectively, we can assume that for part B, it's easier to remove a 3s electron from Mg plus than it is to remove a 2s electron from Na plus. Therefore, sodium is going to have, if we come back to our question, which atom has the higher second ionization energy? Therefore, sodium is going to have the greater second ionization energy. So, knowing these kinds of things, it kind of makes sense when you look at it. Let's come back to our actual setup here. So, in the very beginning of chemistry, you learned that sodium likes to make a +1 and magnesium likes to make a +2. So, it would only make sense in a very practical way. You could skip all this this stuff about your 2s electrons and your 3s electrons. You could skip all of that and just recognize that sodium wants to be +1. It doesn't want to be +2. And magnesium wants to be +2. So magnesium would have an easier time of ionizing to that second level than sodium would. So you can rationalize it in that sense as well.